Presenting mathematics video today on transformations today, and we'll start with the standard approach, and then I'll show you how to do it with functions and sketching so we can confirm. So here's the standard approach. The question is, we are looking at transformations going from y1, which is this equation here, and ending up with y2, which is this equation here. So your first approach is to call the second or the image of the transformation. All the x's and y's are dashed versions. And so what you want to do is you want to make the square root subject, which is the basic form of our square root function. So on the left here, I would have to subtract 3 from both sides and then divide by 2. I will do that step by step. So y take away 3 equals 2 root 4 minus x. They cancel off. And then you'd have to divide by 2. So y minus 3 all divided by 2 is the square root of 4 minus x. And then over here, you want to make the square root of x the subject on the right. So we have to subtract x from both, 6 from both sides, apologies. So you get y dash take away 6 equals negative square root of x dash. And then you would either multiply or divide by -1. I choose to multiply by -1. So that gives me negative y dash plus 6 equals the positive square root of x dash. So we call them equation 1 and 2. What you have to do now is you equate the left-hand sides and the right-hand sides. And then you solve for the dashes. So far, so good. This is the standard approach. Feel free to fast forward to the next bit if this is very familiar. So if we equate the left-hand sides, they are now equal. Y take away 3 over 2 equals negative y dash plus 6. And we want to solve for the dash. So we're going to take away 6 first. So y take away 3 on 2 take away 6 equals negative y dash. And then you would multiply everything by -1. So you get negative y minus plus 3 all over 2 plus 6 equals y dash. And so if we turn that into a fraction, we get negative y plus 3 plus 12 all over 2 equaling y dash. And that gives us negative y on 2 plus 15 on 2. Okay, so that's our y dash there. And then if we look back at our x's, our right-hand sides are these ones. We equate these together. So square root of 4 minus x is equal to the square root of x dash. If you square both sides, that means you get rid of the square root bracket, and that gives you 4 minus x equals x dash, which is already with x as the subject. So we combine these two. Our transformations are our x's go from x to negative x and then to negative x plus 4. And our y's go through a reflection, so it's negative y, and then multiply by half, and then add on 15 on 2. So our transformations here are, I'm going to write these down. X transformations first. So we have I prefer to draw them out first, actually. We have a reflection this way. And then we have a movement to the right by 4. These are the x transformations, which I'll stick with blue for. And then for the y transformations, which we had for pink, or with pink, you have a reflection horizontally, then you have a multiplication by half, then you have a addition of 15 to vertically. So this is what it looks like in words, having turned them into pictures first. So we have a reflection in the y-axis, translation in the positive x direction of 4 units, and then reflection in the x-axis, dilation by factor half from the x-axis, and then translation in the positive y direction of 15 on 2 units. Okay, so that is the standard approach. For the function-based approach, I go back to how would you get from y equals square root of x to y1 in the first place? So y1 is officially 2 times the square root of 4 minus x plus 3, which if you're going to do this approach, you really need to make sure you factorize every thing in the x bracket. So if I factorize the negative out, that's really a hiding one. And I'm actually just going to do it step by step. So I haven't factorized anything yet. I've just rearranged the argument of the square root bracket. And now if I factorize out the negative 1, again hiding 1, you get x take away 4 inside the square root bracket. So the premise that I'm working on is that I go from y1 back to the original basic graph and then go forwards to the final transformation, which is x dash plus 6. Well, technically we didn't have any dashes. Okay, so if we look at the y1 equation, how we got there from y equals square root of x, your steps going forward, if you started with the square root of x, would have been, if we look at the dilations first, and we do them with the same color coding, our x's are blue and our y's are pink. And so our x transformations are where you have a dilation by a negative 1. So it's going to reflect horizontally. And you also have a shift to the right by 4 units. That takes care of your x's. And then your y transformations, I hope I've got the colors right, are, I made that too big. That's all right. Let's do that. Your y transformations are where you have to multiply by 2. So that's a dilation by a factor of 2 vertically, and a shift upwards of 3. And so what I do is I map backwards how I get back to the original square root function. So I basically reverse these steps and I write them out here. So the opposite of adding 3 vertically is to subtract 3 vertically. The opposite of multiplying by 2 vertically is to multiply by half vertically. The opposite of going to the right by 4 is to go left by 4. And last but not least, to reflect, you just reflect again. Okay. And so that takes me from y1 back to y equals square root of x. And then I look at going forward from here to, from y equals square root of x to our final destination, negative square root of x plus 6. And so from there, these two transformations are only two of them. One of them is a reflection in the, they're both y transformations, sorry. One of them is a reflection vertically, so we go like this. And another one is a upward shift by 6 units. And so if I combine these two together, I should have the same net result. So if I take it a step at a time, first we start with x and y. Our first transformation goes to y take away 3. Our next one multiplies everything by a half. And then our next one goes left by 4. And then reflects, so negative brackets x take away 4. Okay, and our next transformation is a vertical reflection, so our y changes, so everything gets multiplied by a negative. Notice it only happens once, and then we add 6 to that. And so you can hopefully see that it's the same result as before. Maybe it's not so obvious. So let's expand this out. So if I take this bit here and expand it out over here, if I expand out the half, negative half, I get negative half y plus 3 on 2 plus 6. And 6 can be written as 12 on 2. And so that gives me negative a half y plus 15 on 2, which is exactly the same result as we had before. So this final step here for both of them is exactly the same result. So personally, I think it's helpful to know how to do both ways. And especially because if you have a chance, you can actually check this in your calculator. So what I did first was I plotted y1 on Desmos, which is 2 brackets square root 4 minus x plus 3. So it starts at 4, 3, and it swings to your left and up. And if we apply the transformation using function notation, what has happened is your x's have changed. So if I have f of x is my basic function, then when you have a minus x plus 4, when you write it in function notation, you're going to have f of negative x take away 4. Remember, everything's factorized in the x form. If you like, you could have also done it as f negative x plus 4. Both of those are exactly the same. And the y bit means that you have to multiply f by a negative a half. So f negative x plus 4 times negative a half. And then you add on the 15 on 2 at the end of that. And that's what I've done in my, I'm going to call it f2 of x. I've done it in my Desmos over here. I've got negative a half f bracket x, negative x plus 4 plus 15 on 2. And that is my final version, the blue graph over here, which I'll pick up over there. And so to confirm that it's right, I just type in the second graph, which is square root of x, negative square root of x plus 6. And when I click graph, it actually sits right on, it should, if we've done it right, sit right on top of the blue graph, which it does. So hopefully you can see the green change to blue. And so that means I've got my transformation right and I've got my function notation right as well. Okay, thank you everybody. If you found this useful, please like, subscribe and share. And I wish you all the best for your year. Thank you. Bye.